Hi, Algebra 1. In Lesson 10 here, we're going to be looking at graphs of functions that are both in standard and factored form and seeing if we can identify what parts of these equations are telling us about the graphs. Here we go. The idea behind this question was just to remember our linear equations and how the different pieces of that equation are seen on the graph. In this case, 8 was your y-intercept and -2 would be the slope. And if you calculate or draw that slope triangle, you'd be able to calculate that slope to be -2. Yes, this is written in standard form, and that's because we have a squared term in there, and we don't have any parentheses, we don't have any pieces being multiplied together. In number 2, Jada says that this is the same thing as our original function. It's just written in factored form, and you have to show that she's correct. So you could use either a diagram or the distributive property, but either one you do, show that when you multiply this out, we get the exact same function. I decided to do this with a diagram, and I got my -16t squared. Here's my like terms. I combined those to have a positive 78t, and then plus a positive 10, and I just rewrote it in the same order that we had to start with to show that they are the same thing. My vertical intercept was at 0, 10. That means that at 0 seconds it was 10 feet off the ground, or it started 10 feet off the ground. And my horizontal intercept is at 5, 0, and that means that it hit the ground at 5 seconds because then it was 0 feet in the air. Now we're going to look at some expressions and their graphs, but without any context, without saying that we're throwing something in the air or anything like that. They're going to show us both the standard form and the factored form of the same equation. So if we multiplied this out, you would get, or if you multiplied out the factored form, you would get the standard form. We are looking for first the x-intercepts, and that's where it's crossing the x-axis. And so it's going to cross at -1, 0, and at -3, 0. And the y-intercept here is at 0, 3. What we really want to start doing is start noticing how do these x-intercepts show up, or how do we see them in either the standard or the factored form, and how does the y-intercept show up, or where do we see it in either the standard or the factored form. Now that you've been identifying these, we need to start calling them by a little more of our vocabulary we're going to use. Our x-intercepts are also called zeros of the function. I'm going to put them on the graph as well and label them as the zeros. What this means is that those are the values for x at which our equation would equal 0 if we plug that in for x. And as we look over here in our first factor, if I plug in 3 for x, because one of my x-intercepts was 3, if I plug in 3 for x into this, my first factor would end up being 0. Well, anything multiplied by 0 is going to be 0. So plugging in 3 made the first factor 0, and anything times 0 is 0. Now my other 0 was at -3. So if I plug in -3 for x, now I see that it makes the other factor 0, and again, anything times 0 is 0. So your x-intercepts are important because they are going to be the numbers that if you plug in for x are going to make the whole thing equal to 0.